This question, we can see there's some pictures below that we need to read about so we can properly understand the situation. So we have a container of mass 2,000 kilograms, which we will put on that as a label to help remind us. It's an electrically operated crane shown in figure 1. So it's being loaded onto a ship. The container is accelerated briefly, after which it is hoisted at a constant speed. So there's a period where it's accelerated, and then there's a period where it's constant speed. And of course, that's a very important distinction, because what we know about constant speed is the acceleration is 0. And when the acceleration is 0, the net force is 0. So that means whatever forces are acting on it need to be balanced, equal and opposite. So we know there's always gravity acting downward. But there is then the force applied of the crane, lifting it upwards. We know those must be equal and opposite. So then similarly, while the thing is accelerating, the force of gravity is going to be the same size as it was over there, but for it to accelerate upward, the applied force must be greater than the force of gravity. And so there must be a net force upward causing that acceleration. So that's just what we know there, making sense of that information that we're given. So now we've got, on figure 2 and 3 above, draw free body force diagrams. Oh, when it's accelerating and moving upwards at constant speed. Using longer vectors for greater forces, state what object exerts each force. So we have the weight. This is the easy one to do. The force of gravity. Gravity, weight, the mutual attraction of the crate and the earth. And we have the force applied. And so there can be no doubt about the size. We are showing them and marking them, indicating that they're equal. And the force applied is the force from the crane motor. And then when it's accelerating upward, force of gravity, I'm even going to indicate it the same size. And then we're going to write F applied. We could even write a little net force next to it. And so we've already defined what applied and the force of gravity are in those cases. So using longer vectors, state what object exerts each force. So the force from the crane, force from the mutual attraction, we've explained the froms. The safety limit for the tension in the cable is 25,000 newtons. Determine the maximum possible upward acceleration of the container if the limit is not exceeded. So the maximum possible acceleration, so we know that's going to be the biggest force that's going to be applied. And we know that the net force is ma. And so we want to know the acceleration when the net force is the largest. So we need to understand the relative, we want the accelerations. Let's solve for the acceleration. So we have F net over m. And we know the mass is 2,000. So the limit for the tension in the cable is going to be caused by the net force. But the force applied cannot be larger than 25,000. And so the force caused that it's going to experience, so the force that's going to be experienced that could break this is the 25,000 newtons. It's not just the net force. Because the tension, the safety limit, if there's more than 25,000 newtons, it will break. And if we had a weight that was 25,000 newtons, then the maximum we could apply would be 25,000 newtons, and that would be just enough to hold it, or just to move at constant velocity. To accelerate it, it must be, so the 25,000 must include the weight of the object. And so we cross off our zeros like so, and we end up with 12.5 meters per second squared, which rounds to We have two significant digits with 25, and 2,000 is most likely two significant digits, so we can report 13 meters per second squared, not three significant digits. So the crane continues hoisting the container at a constant speed of 0.5 meters per second. Calculate the power. Well, power is defined as work divided by time, is force times distance over time, and distance over time is velocity, so force times velocity. So the force, we know in that case, is equal to the weight, so that is mg times the velocity. Mass is 2,000. Gravity is 10, and the velocity is 1/2. So 1,000 times 10 is 10,000. 10,000 watts, or 10 kilowatts, is the power output of the crane.